Hi, this is Dr. Wooten. This video covers the tasks I assigned and walks you through the process, giving you an idea of what can be done. Hopefully this inspires you to find your own additional views of the data that you can put in your project. The first thing I want to go over is extracting and cleaning the data, prepping it to be analyzed. You can extract the data from the website, drop it into Excel, verify and clean the data as you prepare it to be saved as a CSV file, read it into R, and begin your analysis. This process took me a couple hours to do. Or you can read the raw data straight into R from the website, parse and clean the data as you prepare it to be analyzed. This took me several days, working a few hours each day to write and clean this code. You can read the lines in straight from the website using the ULR as the pathway and the function read lines. There are two different formats for this data. One has 3 entries, with the middle entry being the name of the storm, and the other one having over 20 entries, with the wind speed and pressure, timestamp, and other information in various columns. The negative 999 indicates that the measure is missing or not recorded. We need to know the sample size, even though this really technically isn't the sample size, it's the number of lines read. Then we need to create a list for the data to be placed in, because each of these are a string, which means we're going to have to parse the data. So I created a variable called data list, which is a list. For each line that is read, I want to split the string at the comma, delimiting it. We can verify we have this information by simply printing the list. Then I created an index for it, as well as a toggle name, which I will assign 1 if it's a heading having 3 entries, and 0 otherwise. Then I can create a subindex of those indices which have the name of the storm in it, and the remaining readings that have the data values in it. Then I created a variable for storm names. From the storm name index, I extracted the storm names. Then I instantiated each of the variables I want to extract from the other index set. Notice, wind speed and pressure are immediately rendered as numeric, whereas I had to go back and change hours and minutes to be strictly a string and parse it later, because it caused issues when parsing it down to the hours versus the minutes. Now that I have a handle on the data, I can add to the data frame the maximum wind speed across all of the readings and the minimum pressure. To do this, I need to distinguish the storm by name, but also the year, as storm names are used multiple times. Then I needed to create a column of storm names across each entry. I counted the number of entries per storm when I parsed the data. Then I parsed the timestamp into year, month, and day, and the hour-minute column into the given number of hours and the given number of minutes. Reading this parsed information in together as a date, I created a timeline that started with January 1st, 1995. Then I reduced the data down to the years that were required between 1995 and 2015. I could have put these variables into a data frame and then reduced the data frame using the following code. I then categorized the storm entries by both the Saffron-Simpson and the Wooten-Choka scale, using both wind speed and pressure. To verify the data was clean and that all implausible numbers had been removed, I created frequency tables and graphical illustrations of the data's distribution. Then I created a data frame of these variables and exported it into a CSV file, reading the data back in to verify that the data had exported correctly. I then commented out this line, as I do not need the data to be reread into the environment. I then started the process of analysis, verifying the data's headings, the dimensions of the data, declaring the sample size, and printing out a summary of the data for the data description. Then I created YearStorm, which is a code that will keep the storms separate since storm names are used repeatedly through the years. And then I instantiated each of the variables. Then in a for loop, I read all of the information for each storm. The storm name, the maximum wind speed during that storm, the minimum pressure, and the scale based upon Saffir-Simpson and the Wooten. Then creating tables and plots, I was able to analyze the data further by storm instead of by entry. Then I started the modeling, first starting with the correlation between wind speed and pressure, and modeling the storm using linear regression. I then switched to residual analysis, which allowed me to look at the errors. We expect the errors to be 0 on average, with a constant deviation. I also used everything but 2015 to train the model, and then used the model to predict 2015 and measured the error that existed. Then for the write-up I gave you, I didn't want to just do all the years together. That's your assignment. So what I did was created variables that allowed me to measure all of the parameters for the storms each year. First, I found the unique storms that year and then ran the analysis. I also included the code that will export plots in the form of a JPEG. You must first open the JPEG, draw the plot, and then turn off the device. And that will close the file, and you can have instant graphs without having to do exports.